within JUMP, I've created some example data to show you what normal, skewed, short-tailed, and long-tailed data sets will look like. Go into Analyze, Distribution, and I'm going to put all 4 into my Y and press OK. And you can see here that we have the 4 types of distributions. JUMP displays them vertically. It may be easier if we looked at them horizontally. And so here are the 4 distributions. On the leftmost is the normal distribution. And what you can see about the normal distribution is that it is relatively symmetric about the mean. This was based on a standard normal distribution, so a mean of 0 and a standard deviation of 1. You can see that because it's only 1,000 rows, we're slightly off of the mean of 0, but the standard deviation is very close to 1. We have symmetric tails on both sides, leading out to just about plus or minus 3. And then in the box plots, you can see the mean and the median are relatively similar with an equal amount of outliers on both sides. For the skewed distribution, you can see here that we are not symmetric about the mean value of 3. So the mean value of 3 is approximately here. And with a skewed distribution, we have a large amount of data to the left in a different setting. So you can see that it's quite a large amount of data here. And then on the right side, we have data that has a tail. You can ask JUMP to display additional custom statistics if you would like. There are other options here for looking at the types of fit that you have. But basically what this will tell you is that your mean and your median are not similar, and you have much greater distance on one side of the mean than you do on the other to the minimum or the maximum. For a short-tailed distribution, they can be symmetric or they can be not symmetric, but in either case, the tails stop abruptly away from the mean. In this case, our mean of about 0.5. The tails don't go very far and they stop. There's no long dragging out of the tails on either side. And the long-tailed distribution you can see here is again also very skewed distribution. Long-tailed distributions can be symmetric with tails on either side that go a very far distance. In our case, we can see if you look at the mean and the median and the minimum and the maximum, the distance between the minimum and the mean is very short compared to the distance between the mean and the maximum. In addition to that, there are a large number of data points that trail way far out to the right. And in fact, we're looking at 10 times the distance from the median to the maximum, as opposed to only a difference of 38 from the minimum to the median. So you can see things that are right-tailed or left-tailed. So they go left to the below the mean or right-tailed above the mean. And you can see things that are symmetric on both sides. But it's very important to pay attention to the fact that only the normal distribution has a mean with symmetric variability plus or minus from the mean, as well as equal length tails.